Hey guys! Today, let's talk about something that sounds simple at first, but turns out to be one of the toughest challenges humanity has ever faced. Why is it so hard to reach Proxima Centauri, our closest neighboring star? I mean, it's just 4.2 light-years away. That's practically next door on a cosmic scale, right? But when you dig deeper, the reality hits you. Getting there is almost unimaginably difficult. Let me break it down for you in plain, simple terms. First, some context. Proxima Centauri is a red dwarf star that sits about 4.24 light-years away. Alongside Alpha Centauri A and B, it's part of a triple star system. And here's what makes it exciting. Proxima Centauri has at least one known planet, Proxima b, sitting right in the star's habitable zone. In theory, that means it could have conditions for life, maybe even liquid water. Naturally, scientists and dreamers alike see it as the ultimate nearby target for exploration. But here's the catch. Even though it's close, it's still impossibly far with the tools we have today. To get a sense of scale, let's start small. The moon is just 384,000 kilometers away. We got there in 3 days during Apollo. Mars? About 225 million kilometers at its closest, and NASA's rovers take roughly 7 months to get there. Manageable, right? Now jump to Proxima Centauri. It's over 40 trillion kilometers away. That's a number so big, it literally breaks your brain. Okay, so what if we just hop in our fastest spacecraft? Voyager 1, launched back in 1977, is still the fastest outward-bound object we've ever sent. It's cruising at about 17 kilometers per second, over 60,000 kilometers per hour. Crazy fast, right? But at that speed, it would take Voyager about 75,000 years to reach Proxima Centauri. 75,000 years. That's longer than all of recorded human history. In other words, if ancient humans had launched Voyager back when we were still painting caves, it still wouldn't be there yet. What about newer spacecraft? New Horizons, which flew by Pluto, travels at 58,000 kilometers per hour. Impressive, but still, about 78,000 years to reach Proxima. Even the Parker Solar Probe, which set the speed record at a blistering 430,000 miles per hour, would still take around 6,000 years. So yeah, even our fastest tech barely scratches the surface of the problem. If you're loving this deep dive into interstellar travel so far, make sure to hit that subscribe button and join the journey so you don't miss any future videos where we break down the universe, one star at a time. Now, let's talk about the why. The biggest obstacle is the tyranny of distance. 4 light-years doesn't sound like much until you realize a light-year is almost 10 trillion kilometers. Even light, the universe's speed limit, needs more than 4 years to cross that gap. For us, stuck with chemical rockets, it's basically impossible. And here's where physics makes things worse: the rocket equation. To go faster, you need more fuel, but more fuel makes the rocket heavier, and a heavier rocket needs even more fuel to push itself. It's a vicious cycle. If we tried to reach even 1% of light speed with chemical rockets, the fuel mass required would be absurd, something like 100 times the mass of Earth. Clearly, that's not happening. So what are the alternatives? Scientists have brainstormed some wild propulsion concepts. Ion drives and nuclear thermal engines are efficient in the solar system, but to reach Proxima, they'd still take tens of thousands of years. Vasimir plasma engines? Better, but still around 2,000 years. Not exactly practical. Then there's nuclear pulse propulsion, the famous Orion project from the 1960s. That involved literally detonating thousands of nuclear bombs behind a spacecraft to push it forward. It could, in theory, reach Proxima in about 150 years. Not bad, but it would require hundreds of thousands of nuclear devices, a spacecraft the size of a small city, and technology we definitely don't have. Another idea is solar sails, giant ultra-thin sails that use sunlight for propulsion. If built big enough, they could slowly accelerate a craft over thousands of years. Still too slow, but interesting. A variation of this, using giant Earth-based lasers to push a sail, is where things get really promising. With a powerful enough laser array, think 100 gigawatts, you could push a tiny, lightweight probe at up to 20% of light speed. That would cut the trip to just 20 years. That's the idea behind the Breakthrough Starshot project. Thousands of microprobes, each the size of a postage stamp, could ride laser beams all the way to Alpha Centauri. Sounds like sci-fi, but it's being actively researched right now. But let's say somehow we solved propulsion. The challenges don't stop there. Radiation is a nightmare. Beyond Earth's protective bubble, spacecraft are constantly bombarded by cosmic rays and high-energy particles. For a decades-long journey, that's a serious problem. Shielding adds mass, and as we already know, weight is the enemy. Then there's dust. At a fraction of light speed, even a grain of sand slamming into your ship would hit like an explosion. A pebble? Forget it. It's like a bomb going off. Space isn't perfectly empty. Dust, gas, stray particles, they're everywhere. A high-speed interstellar journey would be like driving through a shooting gallery. Even if we could protect the spacecraft, human crews introduce a whole new set of problems. A one-way trip lasting centuries or thousands of years? That means generational ships, where entire societies live and die aboard. Imagine being born on a ship, knowing you'll never see Earth or the destination. The psychological, social, and biological challenges are staggering. Cryo-sleep or suspended animation could help, but those technologies are still very much science fiction. And here's one more kicker. Proxima Centauri itself is not a friendly star. Red dwarfs are notorious for violent stellar flares. Proxima regularly blasts its system with radiation powerful enough to strip atmospheres off planets. Proxima b, the potentially habitable planet, sits extremely close, just 4 million miles away. It's almost certainly tidally locked, with one side in permanent daylight, the other in eternal darkness. Between the flares, radiation, and extreme climate, life there, if it exists at all, would be clinging on by a thread. So, to recap, the distance is almost incomprehensible. Our rockets are way too slow. Fuel requirements are impossible. Radiation and dust make the trip deadly, and even the destination might not be welcoming. That's why we haven't gone yet. But here's the exciting part. Despite all this, scientists are working on it. Projects like Breakthrough Starshot could realistically send robotic probes within this century. NASA has even floated the idea of an interstellar mission by 2069, the 100th anniversary of Apollo 11. Ambitious? Absolutely. Impossible? Not necessarily. Maybe that's the point. Interstellar travel isn't just about reaching Proxima Centauri. It's about pushing human ingenuity to its absolute limit. Every new attempt teaches us something about physics, engineering, survival, and ourselves. As Carl Sagan said, by the time we can visit other stars, humanity itself will have changed. Only a mature, resilient species can stare down the abyss of interstellar space and cross it. So will we ever get to Proxima Centauri? Maybe not tomorrow, maybe not in our lifetimes. But one day, I think we will. I hope you guys enjoyed the video, and if you did, don't forget to like and subscribe. It means a lot to me and allows me to bring more useful content like this.